also called a proportion. In a proportion, and only in a proportion, we have a what is called cross multiplication rule. So in a proportion, if this is a proportion and it's correct, it is 2/4 equals 1/2. 2 times 2 must equal 4 times 1. Are they the same?
Yes.
Perfect. So now keep that in mind. And 0, like any number, 10 is the same with 10/1. -3 is the same with -3/1. The same thing here. 0 is the same with 0/1. So now this is a proportion. If this is correct, then this product has to equal this product. But how much is 0 times 0?
0.
Good. So then I'm telling you that 0 is the same with 1 times 5, which is 5. Would you accept this?
No.
No. So then we do not have an answer for 5/0. 5/0 is called undefined. This is a fancy word that really means it does not exist. There is no number that replaces 5/0. It does not exist.
Okay, I got it.
But we had this in limits quite frequently. So please go back and review those limits.
Okay.
So you don't forget this. Any questions so far? Okay, so I like to look at an application and then move on. So I'm going to share and let's look at an application. So I would like to draw a graph, anything you like to pick from 69 to 75, in which we're told, okay, so you have some given information, some conditions, some restrictions, draw a graph, an example. So obviously there are multiple correct answers here. So let's look at that, and then we'll look at one more application and then continue to see what we learned from the second derivative about the function. So now we know what the first derivative tells us. The first derivative tells us what? So let's write it down. So what does f prime say about the function? It gives critical numbers. It gives potential. If those exist, it could have max min. And it also gives increasing or decreasing intervals. In addition to the rate of change, the instantaneous rate of change of the function at any point. What else we learned from the derivative? Critical numbers, max min, increasing, decreasing intervals. So in the next section in 2.2, we're going to look at the second derivative and see what the second derivative is telling us about the function. But before that, I'd like to, oh, I'm so sorry. I forgot that. Okay, so I forgot that I was sharing my screen. So what does f prime, in addition to the rate of change, the instantaneous rate of change of the function at any point where the function is differentiable, where the derivative exists, right? It gives us critical numbers of the function if they exist. And if they exist, they may turn into max min based on the sign of the derivative. And also we have increasing, decreasing intervals. So in the next section, we are going to talk about what we learned from the second derivative about the function. But first, I wanted to also look at a word problem and an example like this. You choose.
70.
Which one?
70.
Perfect. I'm going to copy it and just and stop sharing. 70. You said g of x is decreasing over -∞, -3. and increasing over -3 to infinity. Okay, perfect. Good. So I will use my table just to make sure that I get used to it and I get all the information organized. This is a simple example. You may say, I don't need a table for this simple. I would have to agree. So this is -infinity, -3, and then infinity. -infinity to -3, the function is decreasing, which means that the sign of the derivative is
Negative.
very good. So the function is decreasing. So this was taken care of. Don't cross it out like that. I just want to make a point. Then the function is increasing between -3 and infinity. What is the sign of the derivative if the function is increasing?
Positive.
Thank you very much. So then the function is increasing. Good. So they're not telling us what to do with this. We will decide. If you want to make it undefined, you can make it undefined. If you want to make it what point? If you wanted to make it a point, what point will that be? And you can give me any number you want here if you want to make it a point. But I'd like you to tell me what type of point will that be?
Min.
Yes. A relative minimum or local minimum, and you can give me any number. You can give me 5, 10, 3, 2, any number. It doesn't matter. We can add on whatever we want to add on, as long as we keep all the given conditions. So here's the graph. So at -3, and this is 5. So here it is. The function is decreasing, has a minimum, and the function is increasing. This is my example of a function that is decreasing between -infinity and -3. Between -infinity and -3, the function is decreasing. Between -3 and infinity, the function is increasing. Obviously, the slope shows negative, and the slope shows positive. Okay, so let's look at one word problem to see how this is working. What about advertising? Find the relative extrema and sketch a graph. No, we're not going to do that. There is no need at this point. We don't have enough information. We're just going to sketch the graph using the calculator. But that's what I can do with my beginning algebra class. Just punching in the graphing calculator. Everyone can do that. Is that okay if we illustrate with 88?
Yeah, that's fine.
Okay. So illustrate that. So let me copy. So n of a. So this is 88. And what page am I on? I think I'm on 203, 202. Okay. So n of a equals -a squared plus 300a plus 6. And a is a number between 0 and 300, they say. So n is units. Lowercase a, thousands of dollars. Thousands. Okay. Find the relative extrema. Fine. Let's do that. What do I have to do first in order to find whether this function has a max or a min? What is the first step? What do I need to determine?
First derivative.
Thank you very much. Can anyone give us n prime of a?
-2a plus 300.
Excellent. Thank you very much. What is the next step after I find n prime of a?
Make the table.
Yes, but I need to set it equal to 0, right? Because I need to find the critical numbers. So this will always be defined. So n prime of a equals 0. -2a plus 300 is 0, linear function. Subtract 300, divide by -2, so A equals 150, 150,000. Okay, so A, careful, 0 to 300 and 150. We're given the domain, we cannot play with that. So this is n of A, of course n prime first, and n of A. Good. I know that this is 0. I need a sign here, and I need a sign here, and the function is right there. So please plug in a number to the left of 150 and tell me the sign, and plug in a number to the right of the 0, to the right of 150, and tell me the sign.
The left side would be positive.
Yes, of course. And the right? Now I have to plug in 150 in the function. Okay? So I'm going to share my screen and go here. Okay, in y equals, clear. And I have negative. This negative, when we start, please, the small negative, x squared, and then plus 300 x, and then plus 6. Second in table, I want to plug in 150. And I get, make sure, highlight, make sure, yes, 22506. Perfect. Good, I got it. So the function is increasing and decreasing. On such an interval, we should always determine the endpoints. When we have a closed interval, we're going to talk about that again. So let me go back. I'm sharing. So I'm also going to plug in, oh, I didn't mean that. I also want to plug in 0. I want to plug, I want to plug in 0, and I want to plug in 300. I copy, at 0 is 6, at 300 also 6. Perfect. So now I know that from 6 to 22,506 units is increasing, very clear. From 6 to this must be increasing, from this to this must be decreasing. What type of point is 150? 150, comma 22,506. So A is $150,000 to sell 22,506 units. What type of point is this based on the sign of the derivative?
Relative.
Very good. Exactly what we wanted. So what would you tell? You're going to work for a production unit. What would you tell the manager? Sir, ma'am, if you want to get the maximum possible number of units sold, spend 150,000 on advertising, and this is your absolute maximum. If you spend 140,000 or you spend 160,000, what will you say to the manager?
You won't get the maximum.
Yeah, they won't get the maximum.
Exactly, you will not get the maximum. If you go below or above, you will not get the maximum. Very good. So this is how it works. Moving on now to the next section. Any questions for me? Any questions? Okay, so now let's tell you the page number 217. I just want to prepare that. But of course, we will talk about it first. So please enter 217, 217, enter. Okay, perfect. It's ready, waiting for us. Okay, so in 2.2, we're going to talk about the second derivative. So we know again, I know I repeat. So f prime gives us a lot about the function. It's critical numbers, it's max min, and it's increasing, decreasing intervals. They're all about the function. This gives us these about the function. Now, what will the second derivative give? The second derivative will give, number one, something called inflection point, 4 points. The second item that the second derivative gives is concavity. So let's discuss and see what they mean, and then we'll choose problems. Okay, let me see. I get to